Hey guys, it's Mr. Riz, and we are going to start the second half of Chapter 2. Remember, there are test corrections for the 2.1 to 2.3 quiz. We're going to do 2.5, which is about postulates, so we are going to start our proof section. So we're going to just kind of go over the basics of what everything is. First, let's start with some vocab. Alright, what a postulate is, it's a statement that is accepted as true without proof. So it's one of those things we don't need to do anything to prove. It's just one of those things that's just always true. Well, a proof, which we're going to spend a lot of time, is a logical argument in which each statement you make is supported by a statement that is accepted as true. So every single statement you make within the proof, or when we start doing two-column proofs, every single step is accompanied by a reason that is accepted as true. And there's different things we can use for a proof. We can use postulates, we can use theorems, we can axioms, and we can also use definitions. Next, deductive argument is a logical chain of statements that link the given to what you are trying to prove. So deductive argument is what we're going to use, and we're going to use a two-column proof method every single time. Right, next, a theorem is a statement or conjecture that has been proven. So like the Pythagorean theorem is something that has been proven. There was a lot of work that went into proving that a squared plus b squared equals c squared. But now that we know it's right, it's a theorem and we can use it. Alright, next, a paragraph proof. It's something we won't use too often except for in this section, but it is writing a paragraph to explain why a conjecture for a given situation is true. So it's basically writing out a deductive argument where we give a statement and follow up by another sentence which is a reason. Alright. Next we have a couple things that are just synonyms for other things. A informal proof, which we won't use, is the same as a paragraph proof. One thing that we will use is an axiom, and an axiom is the same thing as a postulate. What we're going to do next is go over some very important postulates that you guys will need to know throughout the rest of the year. And we're not going to abbreviate these postulates. We're just going to have to know what they are and be able to recall them. They're pretty simple. You've probably knew them your whole life now. Alright, first postulate we are going to talk about. Through any 2 points there is exactly one line. So if I have 2 points here, there is only one line I can connect those 2 points with. There's no other line. If I do another line going left to right and right to left, it's the exact same line. Next one. Through any 3 non-collinear points, the keyword is non-collinear, there's exactly one plane. So there is only one flat surface I could put those 3 points on, as long as they're not in a straight line. If they are in a straight line, then I have an infinite amount of planes I can use. But if I have 3 points, so think of this: a line has 2 points, a plane has 3 points. What we're going to do next is kind of do the converse, if you remember from before. Alright, next one. A line contains at least 2 points. So if we have a line, we know that there's at least 2 points. In fact, there's an infinite amount of points on that line, but we know that there's going to be at least 2 of them. Because for the first one, there's 2 points, there's one line. Converse of that, if there's a line, there's at least 2 points. Next we'll do the converse of the second one. A plane contains at least 3 non-collinear points. Well, we knew it takes 3 points to make a plane. Well, that means a plane will have 3 points. The next one's a little bit different. What it is, if 2 points lie on a plane, then the entire line containing those points lie on that plane as well. So it's saying, like, if I have A and B and they're on a flat surface and I draw a line, you can do this on your desk too. If you put 2 dots on your desk and you draw a line connecting those, that line connecting those 2 dots on your desk will not escape your desk. It's never like the line goes up and out of your desk. it stays on your desk the whole time. Here's some big ones that we're going to use quite a bit. If two lines intersect, their intersection is exactly 1 point. So two lines cross, they only meet at 1 point and 1 point only, right there. If two planes intersect, their intersection is a line. So if we think big picture, lines intersect at a point, planes intersect at a line. So it's like going down a step. Next, what we're going to do, we're going to write a proof and prove that plane S and plane T intersect. That's what's given to us. We're going to try to prove that the intersection contains at least 2 points. This is pretty simple. First, what we need to do is state the given. Given that plane S and plane T intersect, what we can say is that the intersection of two planes is always a line. We also know that every line contains at least 2 points. So we can say, therefore, the intersection of plane S and plane T contains 2 points. That was a very simple proof that we just did there. What we're going to do proofs next are 2-column proofs, and they're easier for when we try to do more complicated proofs. We're going to start out easy by just doing algebraic proofs and then work to geometry proofs. Alright, good luck with this section. There's a CYU. If you have any questions, make sure you ask.